There's always somebody, no matter where you're at, there's always somebody better, somebody who knows more, and there's always a lot who know less.
Which is comforting to know that someone knows more than you. That makes me really happy. I don't want to know everything.
It's a lot of responsibility.
Yeah.
That's for sure.
Can I ask a clarifying question?
That would be really lovely. I got like one little thing I want to talk about, and then I want to work on some problems together. I got one I want to do together that I think will be fun.
We like briefly covered basins of attraction.
Yes, very briefly.
When
Like
we're,
I mentioned it last time
Indeed.
in passing.
So when we're looking at like the sheep and rabbit problems,
Yeah.
I'm seeing a point of attraction, but not necessarily like a base.
Well, let's see. So like, which one are we looking at?
For example,
so
everybody's coming to this.
This whole plane is the basin of attraction, because no matter, so basin attraction is just a locale where you can start that you end up at some fixed point.
Okay.
And sometimes they're like that one's all whole, but like in some of those Latka Volterra problems, you know, you've got multiple basins. You know, like actually classically you have like these basins here, right? But if there's a saddle in the middle, then that's going to split the basins.
Okay.
So usually saddles are the split. Does that make sense?
Yes. So
it was Ash Wednesday today, right?
It was Ash
Okay,
Wednesday.
all right. Just checking.
You're like
telling people they got solar for it.
Oh, it's always. I always feel bad because I think people are like, "Are you okay?" And I'm like, "No, I'm fine." Like.
I think this is the place for it to be okay, though, right?
Right.
Like,
you would be shocked how many people have no idea, though.
really?
Yeah, it's okay.
You don't do that?
Same religions?
No, not at all. But I don't know that Kayla does either necessarily. You know.
I know, but I've had past traumas with religion, so it's not really my vibe.
So she says.
No, that's good. Like one time, I think I sent something to you. I said, "This is why I consider religion one of the greatest evils in the world," or something. And I never heard back from you, so I was kind of like,
Yeah.
Like,
No.
I don't know if she agrees.
No, I think organized. I have a lot of thoughts on organized religion.
Okay. All right.
So.
All right.
But it might be due to my trauma. So.
Yeah, absolutely. I had like trauma for no reason. I like had like past life trauma or something.
Oh.
Like when I was in first grade, I was an atheist. It was weird. I was just very rebellious. I like stood up and told everybody in class, like nobody gave a shit.
I was like, how did that go? Was it like just?
It was the beginning of putting a big target on my back with my big mouth, sharing my opinions that were not welcome.
Sometimes it's better to be willing to share your opinion than to not share it at all.
Yeah, maybe so. It was kind of weird though. It was kind of like, hey, like I gotta say something. I had to say it.
I need to say this right now.
And then there was this dead silence, and everybody's like, crickets and stuff.
Like.
Yeah.
Thanks for the welcoming vibe, guys. I feel so welcomed.
Oh yeah.
Okay. Basins
So,
of attraction.
Basins of attraction. You're welcome. So one last little bit, and then let's have some fun problems.
Jeez,
You don't like any other relationship problems? You just don't like that. You're just not into it.
Yeah. I mean, like they're fine.
Was it more you were tired?
A bit of both.
Okay.
So when we were doing it in class, it was like, okay, this makes sense, but like the problem specifically in the book, it was just like, it was like one very specific question, but there was so many different like answers to it, because it was like, would Juliet fall out of love with Romeo? I was like, there's like 2 possible cases out of like 12 that would happen or something, but I didn't want to sit there and write it all because I was tired.
I feel like you probably did an incredible, I think like that was the result of a deep analysis that you did, like just looking at it and going fuckloads and fuckloads.
Look, I was sitting there doing like on the website, and then I was using my whiteboard. I was like, I'm putting way too much effort into this problem. So I just stopped.
It's all good. I know you. Even your things where you say fuck it, you probably put in more effort than most people do.
Unfortunately.
Yeah. So we're all good. I wanna pop this system up here. So we've got x dot equals y minus y cubed, and then y dot equals negative x minus y squared. Yeah. So, where are my fixed points? Actually, I gotta go pee. So can you do me a favor? Could you find? It's a little early for my pee time, but
Everything's off today.
it's a little
no.
off.
But
Yeah, that's it.
it's kind of bleh outside.
Yeah.
Hey.
Yeah. Can you get me some fixed points and classify them, please, friends? I'll be right back.
I think that there was an accident on Lowell today because I saw this car on a tow truck and I was like,
Oh, cute.
Oh.
I love that.
That's great.
As long as everyone's safe, it doesn't really matter. But like, damn, I'm sorry, friends.
Wow. We're delayed.
Let's do
The
it.
door. The door. I didn't
Oh, I got you.
expect to be closed in here. But two great people to be locked in here with. All right. We got anything?
0, 0.
Nice one.
1, 1.
Sounds right.
-1. -1. Yeah.
Is it negative? Yeah.
Because if it's, that would be 1 minus 1, which would be 0, yeah.
Yeah, is that, so yeah, let's see, so, because this one is that, right, so we get all those
Yes.
0, 1, negative ones, and then when you pick each one of those, I guess, yeah, you get it from, is that right? So let's see, so if this is equal to 0, we need that to happen, right? So, yeah, actually, I think this should be a negative one here too, I think. Because when I put 1, 1 into this, I don't get 0. So I think
Yeah.
that though, right, because the x needs to have the opposite of the y squared.
I guess I can't just drop negative signs when I please.
It's all right.
But fine. I'm just kidding.
You do as you see fit.
Thank you. It's good to know that you're okay with me.
I am
just,
totally okay with
I've
it.
decided that this is not how it works.
So what's our Jacobian gonna look like? Zip minus 3y squared, -1, -2y. Not bad. So j at 0, 0 is gonna be 0, 1, -1, 0. That looks like a center because the determinant will be 1, trace is 0.
Mhm.
Yeah.
So I'll have a
Yes, strict, pure imaginary.
word I was
Yeah, pure imaginary. Eigenvalues, so this is gonna be a center, which is sus a bit because,
It's so sus.
sus, no cap. So it's like, I always feel like just like the weird old person trying to be hip. I mean, sometimes this shit just comes out though. Sus is nice, so fast, so few syllables.
I think sus is an excellent word.
Sus is a great word. I like it because I usually have to trim things down, like people's names. Like I often trim them down just because of my mental deficiencies, I guess. So let's see, what's this? It's going to be -2, -1, -2. So what do we got there? We got tau is -2. So we're on the Stableville, but we don't quite know what. And then delta is going to be -2. Oh, so once we have this, we have a saddle. Yeah. And then this seems like it's this will be the same, right? Because there's no x's in there. Or oh no, it won't be the same. New. 0, -2, 1, +2. So now tau is 2.
It'll be the same.
Oh, it will be the same.
Yeah.
Yeah, because delta is negative again, so we have a saddle. So theoretically, we have this center at 0, 0. These saddles are nice and stable, or not stable, but robust, I guess is a good way to put it, because with these values for delta being so far in here, right, so if this is my tau delta plane, little perturbations aren't going to tweak these into other behaviors. But this one here, the center, is iffy. We don't know. It could be a stable spiral, it could be an unstable spiral just as easily because of this y cubed. So I guess one of the things I just wanted to say, like right up front, is that when we have a linear system, so in a linear system, when we predict a center, that is true. Centers are true. And if not, if we have a nonlinear center or a nonlinear system, centers may or may not be. And that's why we were talking about the conservative system. So I know if this came from a physical system with no friction force and no time-dependent driving, so there's no force coming in that depends upon time solely, or in any way, we're going to have true centers when we predict them. There's one other case. There's actually a couple other cases, but it'll get really gross and boring to keep going through all of them. So I just got one more to take a look at, and if we need it, we'll call it. So let me just write up what I said there. So in a conservative system, center predicted implies center exists. In other cases, also in a reversible system, which a lot of physical systems are, especially if they don't depend, if there's no friction in the system. If you make a movie of it and you can't tell if it's running forwards or backwards, that's a reversible system.
So that would include an equilibrium.
Yeah, absolutely. So if I was at equilibrium, that would be, but we're more worried about the holistic thing of it. So not just at the equilibrium, but holistically. So in a reversible system, predicted centers, this is basically a big theorem. This is the version of the theorem we're going to go with. Predicted centers are centers. So what do I mean by all of this? So first off, a reversible system. Mathematically, and and then we'll do physically. So mathematically, not mathematically, mathematically, this means if we change, let y go to minus y and t go to minus t, that the system doesn't change. So we do this change of variables. And we'll talk about how to do that. It's pretty easy. Implies no change in the equations. That's a reversible system. So if I've got this, do this change, I get no change in the equations, the system looks the same, then that is reversible. Physically, can't tell the difference if running forward or backward. So, a couple easy examples here. And this is almost kind of like a bullshitty thing, right? Like, this doesn't really exist in the world. The Trinity, and you can tell us too, because you know all about chemistry. But there's really frictions everywhere, right? There's no frictionless systems, otherwise we'd have perpetual motion, right? So we have to have energy loss in some way. And I guess friction isn't the only way, but loss of energy is the way of the world. Entropy is the way of the world.
What do you say right above y goes to minus y? Is that
Change of var
variable?
yes.
Thank you. Okay, sorry.
No, that's okay. Thanks for caring and asking. So for example here, like undamped pendulum, that would be really hard to tell if it was running forward or backward, or a mass spring system. Can't tell. And the fact that we live in a place where things aren't reversible, that's how we know we're getting older. That's how we know, that's basically what we call time, right? The inevitable fall to entropy of all things. So I read Time, The Order of Time by Carlo, I can't think of his name, he's a physicist.
Yeah, I have it sitting on my bookshelf. I know what you're talking about.
Yeah, that
I don't
book
know
is
exactly.
an incredible book. I highly recommend. When you got time, first read the Greek myth book.
Yes, I know, it's also sitting on my bookshelf.
That's cool, but then read that book.
Why?
What's that?
It's Carlos, it starts with
Ravelli.
R. Yeah.
Ravelli, Carlos Ravelli, The Order of Time, and it's the most spiritually appealing physics book I've ever read, or science book. It's just gorgeous. But he talks about how really at the quantum level everything's just random, right? So there's just these frames of randomness, one after another, and because we are really bad at seeing detail, we blur things together, and that blurring makes things appear to move forward in this thing we call time. So, his example is this: take a deck of cards, and if you take a deck of cards and organize it, you've got the black and the red, and then you just stack those two halves together, and you just start shuffling. So you do a shuffle and you look at the state of the cards. For a while, this state is going to be apparent, right? Because we're really focused on the color. We're focused on the black cards and the red cards. So after the first shuffle, it's still mostly black and mostly red, but then there's some interspersement in there. And if we keep doing that, then because we are really just focused on the color of these cards, it looks like we can see the progression moving forward. But if you just took the original deck and you weren't focused on anything, say you took all the cards and you removed the colors, and you removed the suits, and you just had these cards, you would never be able to tell that things were progressing. So this is just like, being a human, we focus on certain things. We're focused on very gross details about the state of the world. And because of that, it looks like things are decaying, but they're not. They're just random. Things are random. They're gonna keep random. Randomness keeps going. Randomness doesn't increase. Apparent randomness increases. I think I'm getting this right.
That's very interesting.
It's really beautiful, yeah. But he's an incredible writer. So I love that. Wow, okay. Didn't know that was gonna happen. But let me give you an example of how to show something is reversible. And so we had our original system. This was the one we just had. Y minus y cubed, and then y down equals negative x minus y cubed. So we had that center, but because it's nonlinear, because it's from a linearization, we want to investigate further to validate the centerness of that. So is our predicted center a center? And I'm going to kind of go through the proof of this as we talk this through. And the answer is going to be yes, that it is. But first off, I'm going to note the system is reversible. And let's talk about how to see that. So I'm going to replace t with minus t, and I'm going to replace y with minus y. So when I do that, and I take the derivative of x of negative t, so we have to rewrite the whole system. What will this turn into? What is this derivative right here? And then after we get that, we pretty much have this one as well, of dt of y of t, but like minus t. How do I get those derivatives?
I think y dot was x, or minus y squared.
Thank you. Thanks, Kayla. Yes, you are so right. So what does the chain rule tell me about these derivatives? Yeah, what is this derivative?
X minus x t. Sorry, that didn't make sense.
That's okay. So do the outside first, right? So we do the x dot, so it's going to be x dot
Yes,
of
okay.
negative t times the derivative of the inside, so negative 1. So it's just negative x dot
That's actually what I was trying to say. Believe it or not.
of negative t.
It didn't come out, but it did say.
Really? That's what you were
X.
picturing? It was
That's what
just
I saw
like,
in my head, and I was
that's
like,
awesome. That's
how
great.
It came out of my brain.
And then same thing here, right? This is going to be minus y dot of minus t. It's all right. Check it out. Make sure you believe me. But this thing here also kicks in. So y is actually going to be replaced with minus y. And so because of that, so this run here, this is the t goes to minus t, and then when I let y go to minus y, this y derivative actually turns just back into this. Still a minus t, still negative time inside, backwards time. But I also have to replace every y in the system with minus y. And then hope the thing looks the same after I do all the simplifications. So after we do the t goes to minus t, y goes to minus 1. The top equation, x dot goes to negative x dot, as we showed. Y goes to negative y minus negative y cubed. We'll write it all out just so we have it here clearly exposed. And then this is y dot, because it got a double negative, equals negative x. Now notice the x isn't changing at all, and then minus negative y squared. Then our system stayed the same. Sorry. So, right, this just becomes negative, this becomes a positive, but then when I multiply both sides by negative to get the x dot back, it all works out. And then this one, because it's even in y, works out good. What it means actually graphically to have a reversible system is that if you have a trajectory like this, so if I have that trajectory, then I also have this trajectory. The mirror image comes from the minus y, and then the change in direction is from the minus t. Does that make sense? That if I can replace y with minus y, I've got a symmetry over the x-axis, and then the t just makes me flow backwards. Does that make sense? Yeah? So now you can see why it can't be a spiral at the origin. Because if we do this and make a full half a run, it doesn't shrink. It can't shrink on the next round. It literally has to repeat that. So every half circle has to be met with a perfect half circle on the bottom. And so let me just make that clear, especially because Sydney will be watching this. You can't have this. Or in the other direction, I can't have growth either. So we truly have a center because we have a reversible system, and we can make a pretty portrait then. We can get all the details. I kind of want to just look at this thing. Oh, I think there's something really cool in this one, actually. I think there's a heteroclinic orbit in this. So let's see, we got a center at 0. We've got saddles at 1, -1, 1, and -1, -1. Did I get that right? Did I have that? Did that work? Yeah. Cool. So here we have, wait, was the center at 0, 0?
Yeah.
Yes. Okay, it's cool.
We have saddles.
And we have saddles here. So I think what we have is actually a thing like this. We could verify all this. But I think these two saddles are linked with a shared trajectory. This one's out as this one's in. Something like that. So this one must be in down here as well. And then, let's see. Oh, yeah, and then something like this. These two are linked as well. So let's see, this one must be an input, this one must be an output. So this is pretty bad. But it also tells us that the spinning must be that way.
Can I ask a clarifying
Yo,
question?
please
Why
ask.
is that-
Yeah, please.
That says change in dye?
Change
Direction.
in direction.
Thanks.
Change in, here, I'll write it in German. In D direction.
Thank you. Thank you. That's much better.
There you go, yeah. I think this is actually probably right. These are probably like come off like this a little bit. I'm imagining maybe. Trinity, did you happen to have a, like if you have a, do you have the plotter up? Oh, you do? Oh, cool, thank you.
I love this graphing thing.
That app?
It's soothing.
So we'll see if I got this right. There's one thing, it is soothing. There could be one thing I have wrong, and that's the orientation of the rotation in the center. Can we hit some trajectories? It's kind of looking,
What the hell?
yeah.
What the hell?
She's funky.
Yeah. Oh, that's cool. Oh, okay, so I guess the thing I got wrong was these kind of like come off like this. So we get really funky. Did I get the orientation? Is it spinning counterclockwise? Oh, it's clockwise. Okay, I got it all kind of fucked up with that. So just change every direction.
Yeah. Just flip it all.
Just change the whole thing. Yeah, just do everything opposite of what I said. That'll be fine.
Yeah.
Yeah. Did you get that? You getting it too?
Are you getting the same thing as me? So I want to make sure I typed it
Yeah.
right.
She is.
Okay,
Yeah,
I was like,
definitely.
I don't know, I haven't walked over there to see
Yeah.
Wait, what is this? Oh, okay, so we clicked on it.
Yeah, so that's this manifold down here.
You know what that looks like?
What?
Like when you're flying and you're like hitting air and then air's
Oh, like an
pushing,
airfoil?
going,
Oh,
yeah.
yeah.
You know what I'm saying?
Yeah, especially
And it's
yours.
changing
Yours
behind
totally
it.
looks like that. What about some over here? That's good. That whole area is kind of neglected. There we go.
It needs some color.
It needs some color. So I think I did an okay job,
You did
except
a
for the
great job.
rotation. But I could have figured that out by getting a point, right? Just get a look at a point like 0, 0.1, and then I would get that x dot was positive. So, oh yeah, I could have got it so easily. Positive change here, and then y dot is, who gives a shit, really? It doesn't matter. Once you have that x going left or right, you got your rotation. Cool. So I do have a couple other problems I want you to maybe look at over the break. Not much. And then one I want to do together here, unless you have other stuff you want to talk about, which is totally cool. I would like, it would be great if you could read 7.1 through 7.3. That gets a little heavy, so it'd be good to have some preparation on that. We're gonna we're headed toward bifurcations in this 2D realm.
Oh,
Yeah, it's gonna be heavy. Yeah, it's pretty cool. So this is it's not quite there, but this is an important component that we need to understand, these limit cycles. And then these problems, 651, 652, 663, and 6513. One of those is really pretty. I think 663 is really pretty. You might have already done something like it, Kayla, I kind of feel like, but there's a little bit extra with your plane filled with
oh no,
your spirals. I think that this one's gonna be something like that. I think. Thinks, but I might be totally wrong. I might be totally wrong. And then today I kind of wanted us to just look at this one. I've never done this problem. So let's do this together. Because it's cool. It's like a paper airplane model, and I just want to understand it a little better. So let's all take some time to just look into it. Let's see. You both have books, so you're good to go.
I think you did a great job drawing this because this one's not an easy one by any stretch of the imagination.
Which one?
When we just did in class.
Oh.
You're
Yeah.
like, oh, I didn't do that. I disagree, sir.
Thank you. Thank you. Oh yeah, and this is a heteroclinic orbit right here. This orbit right here. It's because it requires two different nodes that are linked in a parent cycle together. That's a pretty fragile cycle though. It would be almost impossible to achieve in reality. Alright, this is 6514. I'll get the details on the board. Now see, there comes the snow.
No. Oh,
Yeah, I'm gonna fucking call the day off if it gets too bad.
Oh, do you need the problem?
Did you get them?
Yeah.
Okay.
Did you get
Then
one?
it's okay. I was busy drawing. I didn't write down the site.
Oh, sorry. Okay, cool.
No, no,
Thank
it's
you.
fine.
You got him?
Yeah.
I had this feeling while I was erasing this. I was thinking, I bet someone didn't get this.
That would be me.
But you know what? It's so easy to remedy. Like it's
I was having so much fun.
a non-problem. What's that?
Yes.
I just need to know what I'm doing over break.
You don't know yet?
No, like in
For
terms of
homework.
homework
Oh,
stuff, but
oh. Are you staying here?
No, I'm going home, but home is 20 minutes away, so
Yeah, but you're not traveling anywhere, like going
no.
Utah or
Party.
anything.
No.
We're not going to the
I
beach.
love Utah. I hate the politics, but I love Utah.
Utah's pretty rad. They've got lots of rocks out there.
There's many. I like what I used to do when I was out there. I'm just glad I'm not in prison.
Okay.
So we were
What?
just with my friends, just out there
Just doing normal friend things.
doing normal
Oh.
illegal friend things in Utah.
For a second, I was like, maybe he's talking about prison politics in Utah. And
Oh,
Cause you just
no,
said I don't like
it was
politics. I was
kinda-
like, okay, like
Yeah,
maybe.
yeah. It's like, did he kill someone in
Awesome.
No, I mean, Utah's got some special.
They
Yes.
do make a fancy V.
Ooh, a fancy bee.
Yeah, I don't, and this model itself, ooh, that's interesting. Yeah, this looks challenging. It might not be. It's like a very small problem. So let's see. So this is a glider at speed V at angle theta to the horizon. Horizontal. Okay, so here's this. And this is my glider. And I guess it's probably going down, right? Like, so that's theta. That's my glider. And then V is its forward velocity, I guess. No, I guess it's just its velocity in the vector of its direction. So its motion is governed by this dimensionless equations. So the trig term represents the effect of gravity. And the V squared is drag and lift. Help. Help me understand. How can we understand? So how is that gravity? So it's dimensionless, so like this, I guess that's really just like the direction that gravity is pulling relative. What does that mean? So if this is theta, I guess that's sine of, oh. So I guess that's sine of theta, right? And then the cos of theta is this. So I guess without that, this is weird. I find that a little disturbing, that V on the theta dot.
I also am uncomfy. However,
Yeah. Does this make any sense to you? Like, and you've done some aerodynamics and stuff kind of too. I don't know how,
I mean, it's normally not written this way.
Yeah.
But to me, it makes sense so far.
it makes some sense?
great.
I mean, the V with the theta dot is a little funky, but
Okay, you find that a little strange too, yeah?
yeah, but I feel like it'll make sense.
Yeah.
once I look at it.
But well, hopefully, once we get the trajectories, that's when I'm hoping things will come together.
Yeah.
So, let's see, what did they ask us to do first? Suppose there is no drag. Okay, that's chill. So no drag. Show that v cubed minus 3v cos theta. So let d equal 0. Show that v cubed minus 3v cos theta is conserved. All right, well, now we have fun. And I think I have an idea of how to do this, but I'm gonna let you. What do we need to do to show that's conserved?
Closed and conserved are not the same word.
No, So why were you thinking about closed?
I don't know. That's also a great question. And I too ask myself.
How do we do that? How do I prove that?
Can't be constant on open sets. That's all I have written down.
That's
So,
true.
It could be constant on a closed set.
Could be constant, and it will be constant on a
Closed.
closed set because it's a trajectory, right? Like on those trajectories, it'll be constant. So, what does it mean? So what does it mean that this is conserved? What does that mean? Let's just work it together.
Oh. I don't know if this is very mathy terms, but like, it's contained. Doesn't
Definitely.
fly off into the distance.
True that.
It must stay in a place.
Yeah, and it stays constant, even more specifically. So show it is conserved means to show that for all v and theta that satisfy this system, this is constant. If, and the caveat is if v and theta are solutions to this. So where do I go next? How do I move from that to being able to use this information? Well, I'll eat more food. Well, that'd be great. Works for me.
Some snacks.
Some snacks.
Can I ask a clarifying
Mhm.
question? What is the v cubed minus 3b cosine theta? What are we doing with that?
Okay,
Like, what's happening?
so last
We have a
time,
system.
yeah. So remember last time we had a system and we were talking about energy being conserved. So the potential plus the kinetic was always constant.
Yes.
So there was some quantity that represented those that never changed along trajectories. Once you had the energy on that trajectory, it never changed the total. So this is something like that. We don't know what it represents here. This is a quantity that is conserved. So the goal is to show that we have a conservative system because some quantity is conserved. I don't know what the hell that represents.
Okay.
But how do I show? So we've got this, there's no derivatives, the system has derivatives, I haven't used the system yet. I'm going to differentiate with respect to t. And show that that derivative is zero. So show, i.e., show d dt zero. All right, go forth. And hope things work out, I don't know. Remember, d is zero. Oh, this turned out really chill, right? We've got a we know that our system is very simple right now. These are both negative too. That's interesting. Just look, check out my derivative. Gotta use the chain rule. These ones that are more sophisticated quantities. So I would say, for my narrative, towards this end. get that. I don't know, yeah, so now it's just like putting in the puzzle pieces, these puzzle pieces, and can we get that to be 0 from this? That's the interest, that'll be the fun, that'll be the puzzle. Well, shit. Yeah. Oh. Yeah, this 3 should be, oops, is that what you were about to say? Yes, I thought it at the exact same time,
Doing it
yeah.
in my head, so I wanted to make sure I
Yeah,
was
yeah.
just like blaspheming at only 10:20.
Thou
in the
shalt
morning.
not
That would be.
diss the coast. I can kind of see what happens here, right? Because here's V theta dot. So that could become a negative cosine. And then V dot is negative sine. So what does that mean? This first part is the part that looks a little weird. So we're gonna get -3 negative sine theta cos theta plus sine theta cos theta.
I'm not trying to be slow. Why do you say that B theta dot is minus cosine theta?
Because I'm looking at our equations here. So when we let, oh, there is no D in the second one, is there? And that's great. That's fucking great.
Okay.
Oh my God, well, kind of. But yeah, I think yeah, so let's see, instead, so Kayla, what I should have said is that V theta dot is negative cos theta plus V squared. So then this quantity becomes minus sine of theta times, I'm going to replace V theta dot with this. Does that make sense?
Yeah, I was just
Yeah.
curious why we left the B squared out. And I was like, he wants to play too.
I really like the ash.
Oh, really?
It's just so different. It's just so different, you know? It just shakes up. I love it when things are like just out of the ordinary.
Just different.
Just different.
Hey,
It's
I'm
freaking
glad that I could do that for you.
You did, thank you. And then I think this sine cosine, that sine and cosine will cancel, and we'll be left with negative, negative, positive, so positive 3 sine theta v cubed. That should be v squared. All right, there we go. Does that look okay? Now we just gotta get the V dot. Oh, we're done. Yeah, because V dot is negative. Yeah, beautiful. Very beautiful. All right, so this. Yay, showed the derivative of 0. Okay. Got a feeling there's a center in this thing that we're gonna need that for.
Oh,
Ooh, I posted a TikTok. It's getting a lot of likes. Never happens.
what was your TikTok
I'll
about?
show you.
This is what I
Happy to
saw.
be friends on TikTok too. If you're on there.
I don't have TikTok.
Good for you. That's smart. Are you on there?
Unfortunately, but I don't.
We don't have to be friends if you don't want, but I'll
I
be your
don't make
friend if you want. You don't make TikToks?
No.
I had TikTok for like the first 2 months of quarantine, and it made me really sad, so I deleted it.
it does, it drains yours.
I love her. I like the air tag, so you can't lose her.
Yeah.
Oh my god. So happy. Like, could possibly be any happier. Just
Pure. Yeah, she's happy little, for the most part. All right, let's do the face portrait with no drag. That shouldn't be too bad. So we know that there's probably a center, and it will be a true center. Oh, but this is weird, right? We got to divide by v as well. Well, wait, what are our fixed points, actually?
We've done nothing.
Did we do that? We,
No.
no, okay, yeah. So it does look like 0. Well, wait. This gets weird, doesn't it?
agreed.
So let's see, okay, so we would need sine of theta equals 0, and we would also need cosine of theta equals v squared. Yeah, does that sound right? Okay. So this is gonna happen when theta is a multiple of pi. Yeah, and then I'm gonna put that into here, and cosine's gonna alternate plus and minus ones. But v squared is a positive quantity, so when cosine of theta is negative, that's not gonna be one of our fixed points. Does that make sense? Let me say this. So let me write it out a little bit. So this is k, it's all integers. And then, does that, yeah? Oh, did I do something?
Don't we need to put our drag term back?
So this, we're doing it without the drag
Oh,
first.
Okay.
And
sorry.
then we'll add that in.
Sorry.
So this is the, like, happy scenario.
Okay.
So,
Happy scenario.
when theta equals k pi, cosine of theta equals plus or minus 1, v squared has to be greater than or equal to 0. So we need cosine of theta equals plus 1. That is going to happen. That is going to happen at even multiples of pi. So I think we can, yeah, let me know if that makes sense. We can, let me know if you want to talk about that. So from this top equation, we get that theta has to be a multiple of pi for that. But then, so when I plug in those multiples of pi here, for some of them I'm going to get cosine is 1, and some I'm going to get cosine is minus 1, but the minus ones can't be true because this quantity is positive.
Oh.
So I'm going to cut out the half of them that
Yes.
where I get negative cosine.
So that we only have to have
And so yeah, so yes,
K's.
so theta is going to be 2 pi k, and v is going to be plus or minus 1. Because then, so when theta is equal to 2 pi k, that implies cosine of theta is 1. That implies v equals plus or minus 1. So wow, this is crazy. Okay, our plane, let's make theta the horizontal axis, just because it's going to be quite a strip. But I guess we could imagine this wrapped on a cylinder as well. That's probably the way to do it. But let's just get it all out here first. So we're going to have along plus 1, so I'm going to have like positive 1, 2 pi. I'm going to have negative 1, 2 pi. And then 4 pi, negative pi, and 0 as well. Neat. Let's get one more over here. All right, let's classify theta dot. I think we're cool because V is gonna be a positive or a non-zero number, really far away from zero for us. So this isn't terrible. I would use this equation then for theta dot. Don't forget to divide by that V. And then with respect to theta is going to be the inverse sine of theta. And with respect to V is going to be positive, so it's going to be cos theta over B squared plus 1. Interesting. I think that is correct. Stuff. Yeah. So probably just two classifications, one on the top row and one on the bottom row, but doesn't seem like these, yeah, since these functions are the trig functions are 2 pi periodic. Once we get one set, we've got them all. So we'll just do, well, hell, 2 pi k, comma 1. And none of this is good shit. I don't think we're gonna get anything different from plus or minus 1. I think it's always gonna be, and check me out on this, please. But I think this will be our matrix. 2. Wow.
That's a super quick question.
Yeah.
So, is your Jacobian upside down because you write theta, comma v?
Oh yeah, I mean, yeah, I guess it is, but like, it doesn't really matter what order we have it in, really, like in the end. It doesn't, it shouldn't matter, no, as long as everything keeps consistent, everything will
All that
be,
matters to me,
yeah,
I just wanna make sure.
we'll be hunky-dory. I just wanted to like pretend like the theta was the X thing, so like,
That
Kayla,
makes
cause
the most sense, I just was
Yeah.
confused because, okay, yes.
no, but I could like just put that one above that, right, and.
Okay.
Yeah, I think that's okay. That's a good question, though. I think I was wondering that myself when I did it. I convinced myself to just go ahead.
Just do it.
Just freaking do it. So what do we got at those points? And then, like, what does this mean? My God. Well, there's no centers. I mean, unless I did something wrong, do you? Could I have done something wrong here? I guess I expected centers because that's kind of what this whole section's about. But I'm seeing saddles, right? I'm getting.
Oh, but that would be really cool.
It would. It's
Because
gonna
it
look
would
pretty
go
awesome. Yeah.
It'll look like a sinusoidal, but it's
Yeah.
just a composition of cells.
Yeah. Oh, I know who could help us with their plots. We can get you to please get us a plot.
Oh. I'm trying to say, I would not like to do this not per is the wrong word, by.
Well, we'll do, yeah, I just wanna see if we're even on the right track. Cool. I like the sound of that.
No, because
No.
I.
Oh,
I don't-
Jesus.
Don't look
Yeah,
at it. Don't look at it. Don't look at it.
You can clear, go to admission
Oh,
points,
you
and I think you can clear all curves. There you
Thank
go.
God, 'cause I was like,
Yeah,
what
yeah.
the
You might want to increase the like resolution a little. Well, wait, those are centered. Boy, something is wrong here. Because I
Did you get it to work?
I don't know. It's really bad and weird and
Because
terrible.
mine won't even come up.
I probably typed something in wrong though, because you have to convert it to X. Because I did theta as my
yeah.
X. And then
Oh, so this one should be Y, because the V and the theta are mixed there, right? Like if you've got V dot at sine theta, if your X is V,
I did. Oh,
then, yeah, yeah.
right. Okay, so then this needs to. I have to swap all of these?
Let's see, and then the next one, you got Y dot.
Because, so then
So,
that
yeah,
means
that should be
that
X.
these are X and theta's
Yes.
I don't get any centers.
Okay.
Well, okay.
Yeah, I think that one was not, oh my God, that's bad. Change the method, go to, oh, you are on front, good, cut up
Wait.
forward.
You don't get centers? No, fuck.
No, so
Oh, no.
Whoa,
That's
yeah.
what I'm saying.
Okay, let me see. I mean, I expected centers, so I'm thinking, what did I do wrong here? So we've got,
I want to make sure that
yeah,
that's
yeah.
right. 'Cause if these
Did
are
you
X,
change
so
the
X
H5
is
to
negative sine
So you're
Y.
letting X be
And if theta is Y, then Y dot is negative cos Y over X plus X. Right?
Yeah, I think you're right. But what I don't understand, let's see here, so then your X is, this is your,
That graphs would be backwards.
yeah, your X is the V
Mhm.
there, okay.
Because if you draw it that way.
Oh, then there could potentially be,
Yeah.
okay, my graph is just rotated sideways from
Yeah.
yours, okay.
'Cause if this
Okay,
is
that's not too
theta
bad.
And this is theta.
Are you getting,
this is really cool.
good lord,
I'm just
looks like, yeah.
clicking
Yeah.
around.
Okay, hold on. I'm
Wait,
gonna try
so
something.
shouldn't this repeat?
I'm gonna
It
try
should.
something.
Hold on.
If
But I
you-
think it's
If
just-
you make it.
Yeah, you gotta pull back out.
It's
Can I type with you?
Yes.
Ooh, can I clear? Do you mind
Of
if I
course.
clear? It's
Go ahead.
crazy to look at. Okay.
Because if we flip
Yes.
everything.
Yes. So, and let's do more segments just to kind of see how much prettier that is, so you can increase the resolution. Way better. So you're definitely seeing centers.
they've just gotta be so tiny.
I
It has to think about it.
It's
It's
so
not
bad.
you.
Let's
It-
actually go
That's
to a
the
better
problem.
method. You got it?
If we do it the other way, or Jacobian,
Yes.
we get centers.
Then, you were, what did
Oh.
So if you just flip our matrix down there.
Because, so I mixed things up,
Yeah.
because I should have done the derivatives in the different order. That's the okay. So you were really onto something. I like, it's okay to switch the equation order and the Jacobian order, but you also need to change the derivative order. So like, I didn't consistently follow through with my change here, so let's fix this up.
Okay.
So my Jacobian, I think it should just be flipped, the row should be
Yeah.
flipped.
Yep.
Yeah, good shit.
Good
Yay.
shit.
Good shit, so,
My thing that says flip it, because I don't want to read it.
Zero.
oh, this is the zero, yes, thank you, yes, and then negative
Yeah.
cos
Mm-hmm.
theta, yeah.
Okay, hold on.
Wait, is that, and then this one's backwards too, I think. Because this is with respect to V. Yeah. Yep. Yeah, so these are backwards too. So I have to rewrite this. Negative V inverse cos theta plus V. Then this is with respect to V, and so then that becomes V to the negative second cos theta plus 1. And then this is the derivative with respect to theta, and that is plus V inverse sine of theta, and that shit's gonna be 0. Fuck yeah. All right. There we go. So J of, so my thetas are 2 pi k plus or minus 1. So that is 2 minus, no, I'm swaying. This derivative must be wrong here.
I think there's,
This derivative's definitely, wait, what's up? What?
apparently that was this, and let me, hold on, 1 second.
Something is still a little awry here. I'm just gonna
I
start,
think
yeah.
I disagree with your derivatives on the top.
Okay, you mean right here?
No, the first one.
Up here?
Sorry, the first, F of, yeah, F, correct. Okay, the V to
Where-
the negative 2 cosine theta plus 1.
This one here? Okay,
Agreed. I think it needs to be negative
okay, let's see.
because it's minus cosine theta plus V squared over V. But also we're not taking it with, would not just be, we're taking it with respect to theta. So it'd just be minus, or sine.
I gotta rewrite the whole
Yeah.
shit.
Okay.
This whole shit is
Try again.
crazy. So, all right, so theta dot is negative V inverse cos theta plus V, and then V dot is negative sine theta. That's all chill. And so I'm gonna have this in my first row, theta first. All right, so the Jacobian is gonna be derivative of this with respect to theta, which is positive V inverse sine theta.
Yes.
Okay. All right. Yep, okay, this is good. We want zeros in these pockets here,
Yeah.
so that we can get actually imaginary things. And then with respect to V, now this becomes, so this is the one you were questioning.
Yes, that one needs to be negative.
So, so when I take the derivative with respect to V, the negative 1 comes out in front, and that goes to a negative 2.
But the whole term should be positive. That's what I was.
Yeah, okay, gotcha, okay, I'm with you. We agree?
Agreed.
Yes, and then this one with respect to theta is negative cos theta and 0. Yeah, and we're gonna get a positive determinant finally, okay. That is great. So this is J of theta, is that. And so then, at the points of interest, which are 2 pi k plus or minus 1, we're gonna get zip, minus 1, 2. And the determinant is 2, and tau is 0. That's a center. There we go. And because there's a conserved quantity, those predictions are true. And so we've got little circles at all those points. And let's see how much, oh shit, wow, we're out of time. I still kind of wanna, I don't understand the picture. That's what I wanna understand. Let's see, so what direction are they spinning? Well, I guess it's alternating probably, right? Because if we've got that, then they can't,
Well,
oh, what goes around them? Is it like,
if
Oh.
you're in the,
Oh.
if V is positive, it goes, the trend goes toward infinity. And if V is negative, then it goes toward negative infinity. Like asymptotically.
Yeah. Oh, so you two are doing, your pictures are sideways from mine, that's right.
I'm
Not
trying
there's
to-
nothing wrong
I'm
with
trying
that.
to fix it to see if
Why
I
did I
can
do
get it
that?
to be.
Or I plugged it, no?
No, you did great. You did great. It's like, it doesn't matter how you plugged it. You just picked, this was your V axis and this was your theta axis. So, like the same information's
I'm
all
trying
there.
to see.
Yeah,
And
Trinity's thing, yeah.
Oh my
I see your point. I see.
You see?
I got you.
Oh, that's fun. Let me just tell my calc class one more second.